Hello there, class. Good day. Welcome to the first video lesson for the third quarter of grade 10 mathematics illustrating permutation of objects. Take note, this is from version 5. Are you ready? Let's go. Now the objectives. At the end of this session, the learners would be able to illustrate permutation of distinct and non-distinct objects, and illustrate the circular permutation of objects. Definition. A permutation refers to the different arrangement of objects in a definitive manner, in which the order of the objects is important. 4 techniques in counting events or in doing permutations. 1. Making a table is a technique where values or different possibilities are tabulated. 2. Tree diagram is another technique which uses line segments originating from an event to an outcome. This is a picture of all possible outcomes when an event is unfolded. Number 3, systematic listing is a counting technique that involves a complete list of all possible outcomes. And fundamental principle of counting or fundamental counting principle is a counting technique in which if 2 events are independent and one event occurs in A ways and the other event occurs in B ways, then these events occur in A times B ways. Okay, definition: a permutation of distinct objects refers to the different arrangements of distinct objects in a line. It is the different arrangements when no objects are identical or the same. Examples: arranging 3 different mathematics books in a shelf. Getting the possible arrangements of letters of the word read. And choosing a president, a vice president, a secretary, and a treasurer from the 12 members in a club. Are you ready for the illustration? Now, here's the illustration. For the number 1, arranging 3 different mathematics books in a shelf. Say the books are algebra, represented by A, geometry, represented by G, and statistics, represented by letter S. Now, by tree diagram. I am so sorry, I will not use the tabulation method. Okay? So, I'll just use the tree diagram, the systematic listing, and the fundamental principle of counting. At this point, let us look at how tree diagram is illustrated. Take note that we have 3 books: algebra, geometry, and statistics with corresponding representation. Let us now pick algebra first. So if you're going to pick algebra first, then what's next is we can pick the geometry, and then, of course, lastly, we can pick statistics, right? So that's one arrangement. Another, if we pick algebra, we can also pick statistics next, and then the geometry book. So we have 2 arrangements. We have the algebra, geometry, statistics, and algebra, statistics, and geometry. In the same manner, if we're going to pick geometry or statistics first, it will be like this. So geometry, we have, then we can pick algebra, then statistics. Or if we pick statistics next, then we can have algebra last. So we have 2 arrangements, the geometry, algebra, statistics, and then geometry, statistics, algebra. And the third, we have so statistics first, then geometry, and then algebra, or SGA. And then if we are going to pick statistics first, then we can also have algebra, then geometry, or the SAG. So if you're going to look at the bottom part, there we have, there are 6 possible arrangements for the 3 books. works. I hope you understand that a little. Let's proceed to using systematic listing with our given. So we have number of objects. We have three: the algebra book, the geometry book, and the statistics book. Then say we have this AGS for the representation. Then we can list, if we are going to pick algebra first, so we have algebra, geometry, statistics. Then we have also algebra, statistics, geometry. Then we have geometry, algebra, statistics, and then geometry, statistics, algebra. And lastly, using picking statistics first, we have statistics, algebra, geometry, and statistics, geometry, and algebra. So basically, with systematic listing, we also have 6 possible arrangements. Lastly, we have the fundamental principle of counting. In this case, we can directly solve. So we have here 3 objects still for algebra, geometry, and statistics. Before we arrange, we have how many books to choose from? Okay, we have 3. So we have there algebra, geometry, statistics. So if we are going to pick one, say algebra, what's left next? Okay, we are going to choose either from geometry or statistics. If we're going to pick geometry, what's left is the statistics. Then we can have our first arrangement, the algebra, geometry, and statistics. But by looking at the objects, we have 3 there times 2 times 1. That is what is meant by the selection. So we have first 3 and then 2 and then 1. So we can multiply it to have the result 6. Okay, which means there are 6 possible arrangements for the 3 books. By the way, I would like to introduce to you that we can also write 3 times 2 times 1 as 3 exclamation point. Okay, 3 exclamation point is just equal to 3 times 2 times 1. So which is also 6. Now, how to read 3 exclamation point? We can do that as 3 factorial. Again, 3 exclamation point is read as 3 factorial. When you say factorial, then you can have 3 as the highest number and the rest of the lower numbers are factors with the 3, of course. So that's 3 times 2 times 1. Okay, let's answer now the second example. Getting the possible arrangements of letters of the word read, or R-E-A-D. Are you ready? So we have the number of objects, which is 4 or 4 letters. Let us make use of the tree diagram. So these are the objects or the letters of the word read, or R-E-A-D. Now, if we're going to pick R first, then we can have these arrangements. So read, reada, R-A-E-D, R-A-D-E, R-D-E-A, and then R-D-A. That is if we are going to use R first, or use the letter R first. So, if we're going to use E, and then A, and then D, these are the arrangements. So, we can see that in each letter, there are 6 possible arrangements. Therefore, there are 24 possible arrangements for the letters of the word read, or R-E-A-D. That's a systematic listing. Let us make use of the fundamental principle of counting. So we have there number of objects 4. Then we have the letters R-E-A-D. So at first we have 4 letters to choose from. And then if we're going to pick one letter, so if we're going to pick R, what's left are the letters E-A-D. And then from that letters, if we're going to pick another one letter, say E, then what's left are A and D. And then, of course, if you're going to pick A, D is left. So if you're going to look at the numbers of, the number of letters, first 4, then 3, then 2, then 1, by fundamental counting principle, so it will become 4 times 3 times 2 times 1, which is 24. So there are 24 arrangements, or we can make use of the factorial. 4 factorial is equal to 4 times 3 times 2 times 1 equals 24, which means there are 24 possible arrangements of the letters of the word read. Okay, at this point, let us answer example number 3. How many possible arrangements are there for choosing a president, a vice president, a secretary, and a treasurer from the 12 members in a club? Okay, so let's answer this using only the fundamental counting principle, or the fundamental principle of counting. Why? Because it involves 12 members and it's kinda long to show it using the tree diagram or systematic listing. So let's have fundamental principle of counting. So first we have number of objects, 12. So if you're going to select for or elect a president, of course we have 12. Okay, 12 persons to choose from. Okay, so for the position of the president. Now, after electing a president, how many people are left for the vice president position? Okay, of course, 11. And then, after electing both the president and the vice president, how many people can we choose from for the position of secretary? Okay, 10. Very good. And finally, choosing a treasurer, of course, from, okay, 9 people. Okay, so these are the numbers we need to solve for the possible arrangements. Okay, so using the fundamental counting principle, after electing the president, okay, then we have 11. So starting from 12, then times 11 times 10 times 9 equals 11,880 ways. So there are 11,880 possible arrangements. So okay, that's how huge the number is, or the possible outcomes of having a president, vice president, secretary, and a treasurer from the 12 members of the club. So I hope you got that one. At this point, let us have permutation of non-distinct objects, finding the number of possible arrangements of the letters of the word tree, T-R-E-E, and displaying 5 flags in which 3 are red and 2 are yellow. Let's answer number 1. So how many possible arrangements are there in arranging the letters of the word, okay, tree, T-R-E-E? Using the systematic listing, we have there T, okay, R, then E, and let's just make it a small e for distinction. Okay, so now using the letter T first, so we have T-R-E-E. Okay, so these are the possible arrangements of the letters when we are going to pick T first. And then, of course, when we are going to pick R, then E, and then the small e. So these are the possible number of arrangements. But, okay, technically, E and small e are the same. Okay, so what will happen there? To remove all the similar arrangements where E is having this, E and small letter e have the same arrangement, the letters of the word T-R-E-E. So what's left are this. Okay, so 4 for T, and then 4 for R, and of course 4 for E, because we removed the arrangements for the small letter e because it's just the same with the capital letter E. So technically, when we're going to count there are 12 possible arrangements. Get that? Okay, so by fundamental principle of counting, we have 4 objects, but 2 are the same. Meaning to say, 1 is non-distinct, which is the letter E, or 1 is repeated. We have here 4 factorial, but not just 4 factorial, it's over 2 factorial, or divided by 2 factorial, because one object is repeated, okay, one time. So there are 2 factorial. So this is how we write or we solve for the number of arrangements using fundamental principle of counting. So for factorial, 4 times 3 times 2 times 1 divided by 2 times 1, or 24 divided by 2, the answer is 12. There are 12 possible arrangements of the letters of the word T-R-E-E, or tree, of the word tree. Okay, I hope you got that one. Let's proceed to number 2. Displaying 5 flags in which 3 are red and 2 are yellow. So how many possible arrangements are there by fundamental counting principle? Okay, so 5 objects, 3 red and 2 yellow. Technically, the 3 red flags are the same and the 2 yellow flags. So for the systematic listing, you can refer to the module, but I am going to present to you the fundamental counting principle. So we have there 5 factorial for 5 objects divided by, since there are 3 red, so 3 factorial, and then we have 2 yellow, so 3 factorial times 2 factorial are, okay, the divisors. So solving, it's 5 factorial is 120 divided by 12, because 3 times 2 is 6, then times 2 is 12, times 1, 12. So how many possible arrangements? There are only 10 possible arrangements. Okay, that's permutation of non-distinct objects. Now, for the circular permutation. A circular permutation is a type of permutation where the different objects are arranged in a circular manner. Just like, okay, number 1, 3 people are sitting around a circular table. Another, 4 campers sitting around a campfire. So let's try to solve this. How many possible arrangements are there for 3 people to be seated around a circular table? So let's arrange. So of course, we have a blue table and 3 persons sitting there, A, B, C. Second arrangement, so we can put B on top, and then A will be on the right and C will be on the left. And another arrangement, C could be on top, right? And then B on the right, A on the left. Another arrangement, A on top, B on the right, and C on the left. Another arrangement, C on top, and then A on the right and B on the left. And lastly, we have another arrangement, B on top, C on the right, and A on the left. So how many possible arrangements? You answered 6. Oh, I'm so sorry. That's not it. Take note that, okay, in the first row, there, the first arrangement where A is on top, C is on the right, and B on the left, it's just tilted or moved clockwise so that B would be on top. And then another turn clockwise, C would be on top. So technically, there is just one arrangement there. On the second row, okay, the first arrangement on the second line, okay, is just a turned clockwise. So when 3 people are seated around a circular table, there are only 2 possible arrangements. Okay, I hope you get that. If you don't understand this one, please try it in your house. Okay, so that is circular permutation. If you want to solve the second example, so be it. Try to arrange and tell me how many arrangements are there. But before you tell me, I am giving you an assignment to solve. So we have here 2 questions for the assignment. How many possible arrangements are there if 11 campers will be seated around the campfire? And number 2, how many possible arrangements will there be for the letters of the word tendered? Okay, so I hope you will answer this one. So, class, thank you so much for being with me today. Thank you for watching this video. I am Mr. Anthony G. Arisgado, grade 10 mathematics teacher of Bukidnon National High School. If you want, you can share this video to your fellow grade 10 students. Thank you so much. God bless you.